I'm Marty Sachs.
I'm Candy Gardner.
And we both work in maize germplasm, but maize germplasm is really big, so we have a division of labor. I do only genetic stocks, and Candy does everything else.
Actually, our maize curator, Mark Miller, does everything else.
That's right.
We have the inbreds populations and the land races. There are maize collections around the world. Summit, Mexico, has a huge collection of diverse land races. And basically, our mission is to provide the plant genetic resources for discovery, for invention, for helping improve crop production and utilization.
And our focus is on maize mutants and other tools that geneticists and basic researchers use for understanding maize biology, but ultimately to improve maize as a crop plant. So our collection includes a lot of what people might consider the freaks of nature, things farmers wouldn't want to find in their field, like albino seedlings and lazy plants that start growing up normally and then lie down on the ground. Knotted mutants, which look like leaves with varicose veins, and all other kinds of weird things. But they tell us about the genes that are involved in that trait, and with that knowledge of the gene, perhaps we can tinker with them and improve maize. We also have tools that geneticists and breeders use, like mapping populations and translocation stocks that people can use to find genes, the location of genes, and ultimately clone them out and find out what the sequence and where they will fall on the genomic sequence that's being produced for B73.
One of the obvious products of use of the collections is identification of disease-resistant stocks, insect-resistant stocks, stocks with higher productivity, stocks that have special nutritional qualities. The northern leaf blight gene was found in one of the smallest ear-sized accessions that exist, and it provided the basis for crop improvement that enables U.S. producers to combat the threats that northern leaf blight offers.
And although most of the mutants in our collection are things farmers wouldn't want to find, some of them have proven to be commercially useful. For example, the shrunken 2 mutant, which gives a shriveled up kernel. Just fortuitously, a person that was working with that mutant, not for that mutant itself, it just happened to be very tightly linked to a gene that he was interested in, had the habit of putting kernels in his mouth as he was shelling them off the cob and chewing on them, and he realized that those were sweet. And traditional sweet corn is not sweet at that stage, so he knew that that was
mature dry corn stage.
Yeah. He knew that that was a gold mine, and that became the basis of the line Extra Sweet. And what you buy in the supermarket now that's called sweet corn is now all shrunken too.